Very much. Do you hear me?
Okay, yes.
Okay, so if I can share my my first slide. Okay, so dear all, I am really happy, and I would like to say that it is my real pleasure to talk to you today, just in order to follow what you have kindly said during the introduction, the cooperation between our institutions under the joint international Polish-Ukrainian laboratory. I am deeply conscious that organizers give me the opportunity to share our new approach regarding forensic engineering of advanced polymeric materials. So, So during my talk, I would like to focus in the two areas of potential applications of that kind of polymeric materials. The first one concerns biomaterials, and the second one concerns polymeric materials used for the wide branch of packages, since, as you know, polymeric packages are frequently used because of the many advantages. However, they have also some consequences regarding the environmental issue. So this would be these two areas which I would like to focus on today. Let us start first with this frequently asked question, why do polymers are so popular? So the easiest answer could be that because they are solid. Since they are solid, they can be applied in various areas of technology, and this is the reason why they are so popular. However, nothing is perfect. Also, polymers are not perfect, and sometimes they fail in the specific applications. Therefore, the classical forensic polymer engineering focus on the question why polymer products fail in service. This was the first edition of the book of Peter Lewis concerning mostly the technological applications of this kind of materials. The oldest example of failure concerns the ozone crack in natural rubber tubing due to the aging of the polymer under the UV radiation from sun. So this is the example how sometimes the excellent application of the polymeric material can fail in a specific due to the specific reasons. So in the second edition of this book concerning classical forensic polymer engineering, Peter Lewis extended the examples of failures also to other areas, mainly on the medical devices, due to the reason that several examples of such failures had a very strong consequences regarding the social applications. One of the examples concerning the medical applications of the very simple polymeric devices just is on the left side of this slide. As you can see, small crack in the polycarbonate connector could really have a very bad consequences during the treatment of the patients. Another example, quite well known, concerns the application of women breast prostheses, which are very popular in Europe, and not only also in United States, but due to the very small leak, the consequence of the application of that breast prosthesis for several ladies were really horrible. Several years ago, I had opportunity to participate in cost action where we would like to answer the question why some implant materials made from also polymers fails. These constructions were quite international. However, the final conclusion from that action was rather not promising. We concluded that we would like to go and answer the question why some protheses fail. However, the producers were not very interested to give us the examples of these failed materials. This is understandable because they would like to keep it rather in secret and not to expose why their products fail. So as you see, these are the examples where advanced polymeric materials sometimes fail in the application. However, another area where this is also very serious concerns a new development of the advanced polymeric materials, especially also in medicine. I remember when I was young, for me it was very fascinating to go to the lab and to try to discover or evaluate a new discovered material. I was fascinated in the potential applications, and frequently not only me, but several people will try to avoid to think about eventual consequences of their failures. As you can see in the example of that publication, quite known materials based on polylactide and polycaprolactam could also fail in the specific application. Therefore, thinking about that on the broader area, we have recently formulated an extension of that research area, and we call it forensic engineering of advanced polymers. We define that as the evaluation and understanding of the relationship between their structure, properties, behavior before, during, and after practical application. What does it mean? We would like to extend our view and not only learn on mistakes, however, try to predict eventual failures and eventual bad consequences of the materials which we are going to develop. This is the approach which I frequently suggest to the younger scientists also. Try to be a little bit more critical according to what you are doing, not only for the success, but also of eventual drawbacks which we have to eventually predict during our research. Of course, in order to do this, we should have the appropriate approaches and appropriate techniques. One of the techniques which we try to develop in our center in Zabrze is application of polymer mass spectrometry. Why? Because of the discovery of pressure fan on ion trap multi-stage mass spectrometry, we are able to separate individual macromolecules both from homo and copolymers, and these individual macromolecular anions we can further fragment it and learn about their precise molecular structure. In other words, we are able to look on the molecular architecture of polymeric materials on the molecular level to find out what are the end groups of these polymer chains, what is the composition and sequences of the individual merls in the copolymer structure. This technique was particularly useful for us in one of the projects which we already conducted, which was focused on biodegradable polymeric materials based on textiles produced from them for the potential medical application. This project was coordinated by Professor Kruczynska from Łódź Technical University. We are succeeded with the preparation of very interesting materials. However, we use for such materials the copolymers obtained in our center by the group of Professor Dobrzyński by copolymerization of lactate and glycolate using zirconium acetate as a less toxic catalyst than previously used tin catalysts, for example. Therefore, from that material, we prepare non-woven fabrics, and what we found out that very delicate differences with the preparation of these non-woven fabrics can change their physical properties. So in order to evaluate how it reflects to the molecular structure of that copolymers, we evaluate the oligomers found during the abiotic degradation, and using mass spectrometry, we have been able to find out at which part of that structure the decomposition takes place, what are the sequences of the oligomers, what kind of mers are along these oligomer chains. So this was an opportunity to look on that problem from very, let's say, low but very important molecular level. Another example how really small changes in the processing of polymers can influence their properties. It's the sterilization of biomaterials. We have found out that this copolymer, for example, due to the sterilization, lose their molar mass. So it means that some degradation takes place. How to improve its properties? One of the examples we have just presented here, this is the example when we use the blends with analog of natural polyhydroxyalkanoate, and that influences correctly the stability of such material during this sterilization. Another example where in biomaterials details are important is the three-dimensional printing. In case of three-dimensional printing, frequently the people are very happy because we are very, this is the potential to produce very interesting materials also from biodegradable plastic. However, what we have observed is that the properties of that materials depends also how they are printed, vertically or horizontally. When you print them on these two different ways, their physical properties, mechanical properties are different. So another point where we should to predict eventual consequences of the processing of the material. So these were the examples concerning biomaterials. Let me switch now to the another areas, it means to the application of polymeric materials as packages. So the starting point to that is the guidance of the social responsibility, which is in ISO norm 26,000 from the year 2010. And in this guidance, one of the points concerning protection of the environment has been introduced as the information that we have to predict eventual consequences of the application of these plastic materials on the very broad scale. This is the reason why European Commission introduced the European Strategy for Plastics in a circular economy. These are the hopes that at least 40% of plastic bags will be recycled till 2026. There are several other issues regarding recovery and eventual recycling of plastics because of the environmental issues. So the another area concerning that subject concerns application of compostable polymeric materials. That means those which should not make the pollution so heavy. It means that these compostable plastics could be applied in the areas where their application is on particular importance. There are 3 points concerning compostable and biodegradable plastic application in the future defined by the European Commission. The first point concerns the labeling of this kind of materials just to inform the people that this kind of materials could be composted. The second point concerns the life cycle assessment and identification whether the value chain concerning their production is really valuable, and it means that these materials have a sense to be applied in these particular areas. And the third point concerns so-called oxo-degradable plastics, what we call as a kind of the shortcut, which was introduced by the producers of classical plastics with hope that these classical materials eventually can degrade or disintegrate after the UV radiation, but what I usually call it is rather preparation of the polymeric dust. Starting with labeling, the problem is that each European country has different labeling regulations. However, these are connected with the final certification of this kind of materials. In UK, Germany, and Poland, and recently in Slovenia, this kind of compostable material has been accepted. In Italy, it's a little different. In various European countries outside of that I have mentioned, these are different. I do not know whether in Ukraine you have introduced any regulation regarding compostable materials, but one point is that we should be prepared to unify that, to inform the society that this kind of materials are valuable, they are be segregated together with organic waste during the collection of that kind of materials as the waste in the municipal areas. So here you have the examples how popular these materials are now in various European countries. In Italy, due to the matter B production by Novamont, there is no classical polyethylene bag in shops. Only this kind of shops, which are compostable, are allowed, and this regulation helps to introduce these materials in this area, especially in Italy. Then in Germany, in Austria, for example, these materials can be used, in particular, this is polylactide of such enforced structure, are used for the bags which can be used several times, but after their function, they be composted since they are produced from the compostable plastic. The another area concerns also the life cycle assessment. This is the quite long procedure. We cooperate with one Italian company, Eco Innovazione, where they are making for us the calculation of the life cycle assessment of our materials which we are working on. Finally, the end of use of this material is composting. Composting, surprisingly, was mentioned in Poland in the 19th century in the book The Farmstead, edited by Anselm Gostowski. I read this book printed in 17th century. However, this is one of extremity. The second extremity on the right is the homemade it's the home composting system made in USA, and even in each home, the people can use such device to produce compost by themselves. So we use the devices in order to create the laboratory composting system in our institute, where we control the organic waste composition, compost them, then to use that compost for testing of our compostable plastics and measure the evolving carbon dioxide during this composting process. The extension of that was in Zabrze also conducted due to our cooperation with the industrial composting facilities, where we are able to test these materials on the real composting condition, both in the composting pails like here or in the special container system. So we have the opportunity to extend this evaluation on the further areas. Of course, in order to use compostable materials, the infrastructure should be available. In Poland, the amount of industrial composting facilities increased year by year, but still it is not such big, like, for example, in Italy. This violet part indicates the composting available in each country. So this is the way where we have to think about the development of these opportunities for such materials. Several years ago, I had opportunity to coordinate the strategic national product, which was focused on the composting food packages. These were produced in the experimental line in Toruń. Here you have some example of them. And of course, we have tested their composting in the various circumstances at the industrial composting plants, also at the laboratory conditions. However, what was important for us is to be able to extend the application of these short-term packages made of the compostable plastic for a longer application. Surprisingly, we have found out that this material decomposes also when we use the paraffin of even the vegetable oil. So when one of my students in UK tested the three-dimensionally printed polylactide species in this oil after some time, she found out that it decomposed. Why? Because a small amount of water, which is included in the oil, diffused to this material, and that starts the internal degradation of that material. The consequence is we have to predict that for that particular application, this kind of material is not good. We should improve its properties in order to make it useful also as a package of oil, for example. Another area where we have also looked on that concerns the packages of cosmetics. You know from your everyday life that the cosmetics frequently are packaged in the plastic containers and so on. Therefore, in order to use the plastic containers which could be compostable, we have to test it various materials in various areas. For example, in paraffin, in water, ethanol, and so on. And as you can see, that polylactide is not a very good selection for that kind of application because it erodes also in paraffin. When we improve the hydrophobicity of that by making the blend of polylactide with polyhydroxyalkanoate, we can improve its stability under these conditions, and we are able to eventually use that kind of materials to function as a container of cosmetics and then still be able to be compostable. How important is the what we call plastic pollution? We have recently learned, unfortunately, due to the COVID pandemic. Surprisingly, in the proceedings of National Academy of United States, in the paper mentioned here, there was the information that because of pandemic, the various kind of plastic waste from test kits, from personal protective things, from packages of the, for example, of various testers, was not appropriately recycled or even collected during the pandemic. And the pollution goes also to the global ocean. And from the picture from ocean Asia, you can see how many masks these gentlemen collected on the beach. That means that plastics are important to protect us. However, we sometimes, after this protection, make the situation totally different. We spoil the area where we are. This is the reason why we are working now in the European project, which is focused on improving of the packages used in the hospital and medical areas, together with several groups from Europe, Italy, for example, University of Bologna, and also Ohio State University in United States to improve eventually this situation. Of course, we can make something new. However, we should not forget about something which is, already on over the world. It means the classical plastic pollution. As you can see here, this is the example how the polyethylene bag can be found out in the Mariana Trench. So this is the reason why in the interview for Guardian, I said that we are just at the beginning of the cleaning up what has been done by the classical plastic. In our approach to that was, to test the so-called oxo-degradable bags, where we find out that they are only disintegrate but not degrade. And if I can go to another slide, I don't know why. Then working with our PhD student, now Dr. Brian Johnson, we found out that some of these materials can be transferred to the biodegradable plastics by selected bacteria. That concerns polyethylene, that concerns polypropylene, and recently also we tried out to do the same with such material like so-called oxopolyethylene to transform this dust or this disintegrated material to biodegradable polymer. Finally, in this area, we have been able, thanks to the cooperation of the group of Professor Zabrze from the Technical University in Gliwice, to help in the recycling of Tetra Pak, which consists of paper, aluminium, and polyethylene. His technology to separate polyethylene from paper and aluminium by solution of the polyethylene in special solvent at higher temperature and then by production of polyethylene powder was a first step. Then we used the powder after activation as a carbon source for production of polyhydroxyalkanoates using this special kind of bacteria. Therefore, we are able also to clean the area on that way. So I am nearly at the end of my talk, and I would like to say that message to take home is, in our studies, we should think broader from the cradle to grave of the new developed materials and predict eventual consequences of their discoveries. So finally, of course, this is the open question: why, how the Russian aggression to Ukraine can, or even not how, but rather when, will get the influence of that on the situation in Europe. So what I can only conclude in that point is chwała Ukrainie, and I would like to thank my co-authors, the financial sources, and finally, thank you for your kind attention. If I can.
Сергію Володимировичу, продовжуйте.
Okay. Thank you very much for your extremely interesting presentation. Dear colleagues, do you have any questions to Marek? So I have one question concerning sterilization. Would you please tell us which type of sterilization is usually applied for copolymers? I mean, heat or UV or something else?
Gamma radiation is still, I think, the best solution. Application of heat and, for example, steam, it's not good. So gamma radiation, and this is what we could recommend as the best. However, of course, there are some works on the ethylene oxide application, but still for some, especially biodegradable plastics, it is not a very good solution. So I think that the gamma radiation is the only one. Of course, it requires the appropriate opportunities to perform that. But anyway, this is the best till now.
Okay, thank you. Any question, please?
May I ask you? Thank you very much for your very interesting lecture. And I have maybe a general question. It seems that mankind is on the beginning of its war with plastics wastes. Can you say, do we have the real results in decreasing of the plastic waste in environment? A lot of efforts, we see a lot of efforts of in Europe, in US, and in other countries, which are directed to decrease the quantity of plastic waste. Do we have a real results in decreasing of these wastes in environment?
Thank you very much for that very interesting question. You know, the situation from my experience is like that. There are several points which should be taken into account to answer that. First is technology, and from the technological point of view, I can say that we are prepared to replace the classical packaging plastics for the compostable plastics. Then there's the economy, price. In Italy, for example, this plastic compostable bag costs 10 cents, so this is not very high price now. It means the price should be affordable for people. And the third very important is legislation. Of course, for that, we should have the industrial sector, which will be able to fill the gap and to replace the classical plastics where it is possible, because not in all areas, but in the packages area for the compostable ones. That happens in various countries. Step by step, the production increases. However, to optimum of these 3 points, economy, legislation and technology, these are the main important points to play with the future. Without that, we can only have the problems, because classical plastics are still more and more not, let's say, acceptable, but the environment, of course.
Okay, any questions? No questions. Okay, dear Marek, thanks a lot for supporting Ukraine and especially Ukrainian scientists. We greatly appreciate it. And dziękuję bardzo, and have a nice day.
Thank you very much. If you allowed me for one personal, unfortunately sad thing, it happened that my cousin, Professor Iridion Kubishin, was the head of the World League Institute in Gliwice, Poland, passed away last Saturday. I still remember his conversation with me about his cooperation with the Patton Institute, but remember, we are all still with you, those who can do something. So thank you also for your words regarding our support for our colleagues and scientists. Thank you very much. Thank you.
Okay, thank you.